Hello everyone, welcome to this video. I am Akshay Jain and today we'll be discussing part C of my question paper, data processing. So, data processing. This isn't the most glamorous part of our data science, but it's arguably the most critical. It's the essential foundation upon which all our feedback analysis is built. Over the next 7 minutes, we'll walk through the questions and techniques required to turn raw, messy, and student feedback data into reliable, actionable insights. Let's move on. So why is this pre-processing necessary? The reality is that real-world data is dirty. Whether it's from a student survey or a system log, it's full of mistakes. It might be incomplete, like when a student skips a rating, or inconsistent, like giving a five-star rating but writing a negative comment. Our goal is simple: to clean and transform this raw input into a high-quality, usable format. We do this because we want to ensure that our models and our subsequent analysis provide accurate and reliable insights. If we don't clean the data, we fall victim to the famous garbage in and garbage out principle. Uh, Data quality and cleaning. Question 9: Data quality issues. The first step is assessment. Question 9 asks us to identify data quality issues while when evaluating feedback. We look at four main dimensions. We check for accuracy. Is the data correct? Completeness. Are any survey fields missing? Consistency. Does the numeric rating align with the written comment? And final validity. Does the data adhere to predefined rules, like ensuring a rating only falls between 1 to 5? This leads us directly into question 10: handling missing values. While we encounter a blank spot, we have a few options. We can ignore or record entirely, which is fast but risks losing valuable information. For large data sets, the most common and robust approach is imputation. This means we substitute the missing value with a calculated estimate, such as the mean or median of all other ratings for that question. This maintains our data size set while introducing the least bias. Data transformations smoothing. Next, we move to data smoothing. In question 11, smoothing is crucial for removing noise and outliers that can skew our analysis. The required technique here is binning by bin means. The process works by first grouping our data into buckets or bins. The requirement specifies a depth of 3, meaning we group 3 consecutive values together. Once grouped, we calculate the mean or average value of the items inside that bin. We will then replace every original value in that bin with that calculated mean. For example, if a bin has ratings 237, the mean is 4. If every value is then replaced by 4, that smooths out the minor fluctuations, revealing the underlying patterns in the feedback. Let's move on to the next slide then. Question 12 through 15 cover integration and scaling. Uh, Question 12, data integration, is about merging data from different sources. Say combining the student survey data with their academic research. The main challenges are schema integration, ensuring field names match up, and managing redundancy, ensuring we don't count the same place of feedback twice. The core of this section is normalization. Question 13 and question 14, which is about scaling all our numerical data to a common range. This is essential for all algorithms sensitive to value difference. Question 14 asks us to apply 3 specific methods. First, min-max scaling, which scales the data directly to the range 0 to 1. Second, the z-score method, which scales data based on how many standard deviations away from the mean it is. Finally, the question 15, which asks about the use cases. We use min-max when we need a fixed tight range, like for training a neural network. We use z-score when we believe the data follows a normal distribution, as it handles outliers more gracefully than min-max. Let's move on to the next slide then. Analysis and data reduction. Here we'll discuss question 16 and 17, correction analysis, correlation analysis and data partitioning. In question 16, we move into simple analysis with correlation. After normalizing our data, we use Pearson's correlation coefficient to understand the linear relationship between two variables like age and productivity. This gives us a single number between -1 and minus and plus 1. A result close to plus 1 means a strong positive relationship, while a value near 0 means there is no linear relation. Question 17 deals with data partitioning for project evaluations. We essentially want to group scores we can use binning to create fixed predefined ranges like A, B, and C grades. Alternatively, we can use clustering. This is a technique to find natural groupings in the data based on similarity. This is often more insightful than fixed bins because the groups we discovered are by the data itself. Then now let's move on to the last slide, our seventh slide, which discusses the question 18th, feature selection. Our final processing question, pre-processing question 18, addresses attribute selection or feature selection. Our goal is to select only the most relevant attributes, the most important survey questions, to reduce the complexity and improve the performance of our final analysis product. The two dominant techniques are forward selection, where we start with an empty set and keep adding the best performing feature one by one. The other is backward elimination, where we start with all features and systematically remove the weakest one until only the most valuable subset remains. This step significantly improves model efficiency. And you can also see on your screens is the attribute selection description. And this brought us to the end of our video with question 18th and end of part C. And thank you for watching the video. We'll discuss the part last part, part D in our next video. Thank you.